So for 104 here, first of all, this says that if you're using our textbook that there's like a little skill builder for properties of exponents. So again, that's a link that's on the website if you are working through that. But basically this whole question or concept is talking about simplifying expressions using our properties of exponents. So for A here, I'm going to go ahead and kind of like distribute this exponent here to see what we get. In this one, I am going to get 5 to the power of 6 and b to the power of negative 12 times 3 to the power of negative 2 times b to the power of negative 10. And from here, what I'm going to do is I'm going to go ahead and anything with a negative exponent, I'm going to take the reciprocal, meaning I'm really just going to call it 1 over this and then make the exponent positive. And so when I do that and I multiply all these back together, what I end up getting is 5, let's see here, 5 to the power of 6 on the numerator, and then 3 to the power of 2, which I'm going to actually evaluate as 9 with this. And then we have b to the power of b to the power of positive 12 on the bottom and b to the power of 10 on the bottom. So when I multiply b to the power of 12 and b to the power of 10, it becomes b to the power of 22. And so I could technically evaluate 5 to the power of 6, but it's going to give me a really big number, so I don't really want to do that. And so I'm going to leave my answer here as 5 to the power of 6 over 9 times b to the power of 22. For b here, I'm going to multiply all the numerator together first and then the denominator, and then we'll see what we can simplify from there. So in this one, distribute this exponent. So x to the power of negative 3 times x to the power of negative 4, y to the power of 3, z, which when I put these together, we get negative 7, y3, z1. And the denominator here looks like I can't actually multiply anything here, so it's just going to be x in the bottom, y to the power of negative 4, z to the power of 4. And so a couple things that I can do with these, any negative exponents, I can take the reciprocal of or flip them to the opposite side of our fraction bar. So with this, that means that I'm going to actually multiply x to the power of positive 7 to the bottom, and I'm going to multiply y to the power of positive 4 to the top. So what that looks like before we multiply, we got y to the power of 3 times y to the power of 4 times z, x to the power of 7 times x times z to the power of 4. Now I'm going to multiply my y's together to get y to the power of 7, and multiply my x's together to get x to the power of 8. And since I have 4 z's on the bottom and 1 z on the top, one of those z's is going to cancel. So this goes away and this becomes 3. And I get my final answer here of y to the power of 7 over x to the power of 8 times z to the power of 3. So using a lot of different exponent rules there to practice, but there's our final simplified answer for b. For c, I'm going to distribute this exponent, so it's going to go to all 5 of these exponents here. So when I rewrite that, it's 2 to the power of 3, x to the power of negative 6, y to the power of 9, x to the power of negative 15, and y to the power of 21. Now any negative exponents, I'm going to switch to the other side. So when I rewrite this, 2 to the power of 3, x to the power of positive 15, y to the power of 9, x to the power of 6, y to the power of 21. I know 2 to the power of 3 is just 8, so I'm going to stop writing that. Now, with this one here, 6 of these x's are going to cancel, leaving with 9 on the top. And 9 of these y's are going to cancel, with 12 of them remaining on the bottom. So my final answer here is 8x to the power of 9 over y to the power of 12. Last one here, I'm going to deal with this negative exponent first, which takes the reciprocal. So I'm going to have, oops, that's wrong already, 27 over a to the power of 6 all to the power of 2/3. Now I'm going to distribute this exponent to these two spots here. 27 to the power of 2/3 over, what is that, 4, a to the power of 4. And then simplifying 27 to the power, let's do this in orange. 27 to the power of 2/3 is the same thing as saying the cube root of 27 squared. The cube root of 27 is just 3, because 3 times 3 times 3 is 27. And 3 squared is just equal to 9. So my final answer for this one would just be 9 over a to the power of 4. And again, this is just getting practice with exponents. There's a lot of different properties that we need to understand and how to deal with the negatives and so on. So this is a really good problem to make sure we understand that.